we are testing on one of the most complex highway construction sections, a route we've used before with GMP. This route includes approximately 500 kilometers of round-trip driving, with 300 kilometers under construction. In our previous tests, the AITO vehicle achieved over a 99% availability rate. Now, we are evaluating the new DENZA N9 to see if it meets the standards of top-tier vehicles in this challenging environment. This involves assessing their navigation and driver assistance capabilities across varied conditions. Both vehicles started simultaneously with their mileage reset to 0. We calculated the available system distance and its overall reliability. For the AITO, the driving distance was 469.1 kilometers, with an available distance of 68.5 kilometers, resulting in a 99.87% availability rate. In contrast, the DENZA's driving distance was 473.2 kilometers, but with an available distance of 458.9 kilometers, its availability rate was 96.98%. We observed this slight discrepancy while rigorously testing their autonomous driving capabilities. Unlike our previous routes, this test focuses on a two-lane Shanghai highway, which is under long-term construction, featuring many chaotic lane markings and temporary diversions. The challenge is even greater with newly opened sections, not covered by traditional high-definition maps. This route puts the system's usability to the test. From our findings, AITO consistently maintained a very high range of operability, while the DENZA also surprised us with its ability to navigate without relying on high-definition maps. This demonstrates the robustness of both vehicles. In terms of lane changing, we mainly assessed the lane changing strategies and accuracy of both vehicle models. The lane changing experience was similar for both, with proactive lane departure capabilities. However, there were significant differences in lane changing accuracy. The AITO M7 triggered 75 lane changes, with 13 being ineffective, resulting in an 82.67% accuracy rate. Comparatively, the DENZA had 69 lane changes with only 2 ineffective changes, achieving a 97% accuracy rate. These results highlight a disparity in their performance. Looking at lane changing efficiency, the DENZA's total time was 307 minutes with 61 overtaking lane changes, while the AITO took 309 minutes with 52 overtaking lane changes. Both vehicles performed similarly. In urban settings, both are highly proactive in lane changes to overtake slow vehicles, enhancing the driving experience. Notably, we observed frequent instances of both cars using right-hand lane access when needed. However, the AITO's frequent ineffective lane changes might be due to our chosen tool and route, which posed unique challenges. Next, we examined the system's misinterpretation of speed limits. The DENZA mainly experienced misinterpretations due to gantry structures, triggering 2 minor deceleration instances. Regarding safety rules, DENZA showed no violations. However, the AITO triggered 2 instances of lane changing across solid lines. This highlights the nuances in their autonomous driving behavior and the varying impact of road infrastructure on their performance. We are thoroughly analyzing these scenarios. In construction scenarios, both cars started simultaneously, following the same navigation route. However, they chose different lanes, resulting in differing construction experiences. The DENZA encountered 6 construction scenarios, all of which it successfully navigated, whereas the AITO encountered and successfully navigated 3 construction scenarios. Despite using the same route, the varying choices underscore the autonomous navigation system's route planning and execution differences between models. We are documenting each unique scenario encounter. Particularly, both vehicles accurately identified and maneuvered around a construction vehicle obstructing the fast lane, demonstrating accurate recognition and obstacle avoidance. So, having covered the highway navigation, we also previously introduced the DENZA's urban navigation capabilities. This time, we're conducting real-world tests in Shenzhen, comparing it against the AITO M7 to analyze their urban navigation capabilities, particularly focusing on performance without relying on high-definition maps. We are also testing in various road conditions. Starting with the operational range, we expanded our test routes to include not only main roads but also construction zones, secondary roads, and even small roads leading into urban villages. This was to thoroughly assess operational availability. Across the 40 kilometers of diverse roads, both vehicles could activate their autonomous systems for 100% of the distance, including the complex capillary roads. This confirms their very high urban operational range, as we pushed the boundaries of their autonomous navigation. Besides testing operational range, the challenge of urban roads is significant. We tested 42 intersections and junctions, with the DENZA successfully navigating 39, achieving a 92% success rate. Meanwhile, the AITO successfully passed the 6 for an 85.71% success rate. These varied outcomes highlight the differences in urban navigation performance during our extensive trials. We are meticulously analyzing each scenario for insights into their autonomous driving systems. Our testing included standard left and right turns, as well as more difficult scenarios like staggered intersections and elevated roadways requiring multiple continuous passes. We explored these environments to further test the vehicle's autonomous capabilities in complex urban settings. These more demanding intersections are a critical aspect of our testing, reflecting the types of real-world challenges that autonomous systems must handle effectively. Our goal is to understand how these vehicles navigate various types of urban traffic scenarios. We also included complex intersections in auxiliary roads, and the most difficult of all, capillary roads within urban areas. These roads lack clear markings and involve navigating around two-wheeled vehicles, pedestrians, and quickly adapting to the ever-changing road structure. In these settings, the vehicles must predict the movement of other road users and make appropriate path planning decisions. This requires very high levels of real-time understanding of road and traffic conditions. Entering small roads and auxiliary roads puts significant pressure on the no-map autonomous navigation capabilities. Vehicles must have real-time awareness and comprehension of their surrounding environment, and the relationships between different routes. They also need better prediction capabilities for the actions of other road users in the immediate area. This is to guarantee both efficiency and safety during all driving scenarios. In our testing, the DENZA's ability to handle complicated road conditions was superior to AITO's. In complex intersections, the AITO had its system disengage due to a road change, whereas the DENZA was able to complete the pass. Additionally, both vehicles encountered a unique road section, where they moved from a main road to an auxiliary road, which was also under heavy construction. The challenge at this point was that the lane markings were unclear, making it difficult for the system to recognize the road structure. These real-world examples highlight the system's strengths and weaknesses. During testing, the DENZA was unable to pass due to its limitations in interpreting the situation. However, the AITO attempted to make the pass, but did not find an optimal route, leading to the system disengaging. Interestingly, both cars demonstrated the ability to recognize gate arms in narrow capillary roads. A very welcome surprise. This shows that there are improvements that have been made to both models. We continue our analysis and testing of these systems. Both vehicles demonstrated very smooth acceleration and deceleration, resulting in a very refined experience in urban environments. Their ability to handle Q-turns, special maneuvers, and lateral vehicles was very much like an experienced driver. In terms of efficiency, both performed very well when handling situations such as intersections, urban villages, secondary roads, two-wheeled vehicles, and navigating around parked cars. The general level of performance of both models was impressive. During this test, both cars demonstrated a high level of efficiency in handling dynamic traffic situations, particularly at entrances and exits of rivers, urban villages, and secondary roads. The navigation systems handled two-wheeled vehicles and pedestrian traffic very well as navigating around parked cars. Both systems showcased very strong efficiency. Notably, we also observed a unique construction scenario, where the AITO disengaged at a right-hand turn while maneuvering around construction barriers, while the DENZA smoothly navigated and avoided the barriers. The DENZA performed well in this scenario. The DENZA successfully identified the diversion barrels and smoothly navigated around the construction zone. These results demonstrate the real-world autonomous driving capability of the two models, with a particular emphasis on how they handle unexpected or unusual situations. It is important to assess these scenarios as they highlight the strengths and weaknesses of the models in comparison. In urban environments, the feeling of safety is paramount to how a system is received. Urban environments are more complex than highway scenarios with more traffic participants involved. The interaction between the machine and driver is very important. The DENZA and AITO have relatively well-established methods of interaction that clearly indicate what the system is doing. Each maneuver or action has an appropriate visual and auditory cue for the driver. The key to adoption of these systems will rely on a safe and informative user experience. There was a strong focus on ensuring the safety of pedestrians and other vulnerable traffic participants. The autonomous driving systems are equipped to identify and avoid potential conflicts with these road users. This also encompasses scenarios including urban village roads. In each situation, the autonomous systems predicted the pedestrian's path and adjusted the vehicle's position accordingly. These tests show a commitment to safe and smooth operation even in high traffic areas. None of the scenarios created any unsafe conditions. From our tests, both the AITO and DENZA performed well in no-map navigation and their handling of complex environments. They were both able to navigate capillary roads. However, the DENZA demonstrated superior ability in understanding and predicting complex urban scenarios and the interactions between different road segments. The DENZA also performed better in navigating difficult intersections. This result was a bit unexpected and very interesting. We intend to continue investigating these results. To provide a more complete test of the systems, we added 2 difficult parking scenarios to the test plan. We created 2 challenging scenarios to examine the parking capabilities of the AITO and DENZA. Both were difficult U-turn style parking spots. These scenarios will give us a better picture of each system's parking abilities and allow us to make a more direct comparison. We are also trying to determine which model has better capabilities in general. The first parking spot we chose was a standard U-turn style spot with an obstruction car placed in front and next to the parking spot. This was to test the system's path planning abilities. The DENZA used the space behind the parking spot, making a perfect arc on the 3rd attempt, and parking like a very experienced driver. It made optimal use of the available space and demonstrated its parking abilities very well. The AITO M7 required more maneuvering during its parking attempt. It needed an extra adjustment to park in the space, but still succeeded overall. For the second parking spot, we increased the difficulty level even more by using a narrow U-turn spot where all of the adjacent spaces were also occupied. This was to test the ability of the systems to recognize tight spaces and properly plan parking paths within difficult environments. These are very useful tests of the autonomous parking capabilities. The second parking spot we tested was in a very tight space. The DENZA was able to move directly into the parking spot. The system identified the space and used a multipoint turn to park within the narrow spot. It was a very good demonstration of its parking ability in a challenging situation. We were very interested in seeing the parking strategies of each model, especially within a very challenging scenario. The AITO system was able to identify the parking spot and used a more strategic approach. The system backed out of the parking spot, turned the car around using the extra available space, and then parked into the spot. The system took the most advantageous path to successfully park the car. It used the space available to improve its efficiency. We thought that this was a very useful approach in this scenario. Okay, so that concludes our overview of the latest DENZA update. Honestly, when we first got the new system we did not have particularly high expectations, however our experience during testing has greatly exceeded our expectations. The DENZA's autonomous driving system upgrade is more significant than we thought. This is why we added the AITO M7 for a direct comparison of the 2 systems. We were very keen to see the direct comparisons. From the tests, the AITO M7 has clearly integrated its city and highway capabilities. This highlights a reliance on the car's intrinsic capabilities and algorithms for navigation. This includes highway navigation, comfortable acceleration and deceleration, and its handling of complex city roads. In addition, the AITO benefits from a wider available range, which includes places where GPS is intermittent, as well as construction zones, secondary roads and capillary roads. This approach has created a significant improvement in available range. Both the highway and city systems are now more versatile and capable of handling unexpected or difficult scenarios. The result of this is that both models are able to operate in a wider variety of environments, which greatly increases their real-world utility. This is especially true in construction zones, secondary roads, and capillary roads. These are important factors for consumer adoption. The city performance, specifically intersection performance, was more capable than the current AITO no-map navigation system. We are very excited to see the next level of development in their nationwide capabilities. This was an unexpected outcome, and we were very impressed with the overall capabilities of the system. It will be interesting to see how this technology develops, and what level of coverage will eventually be offered.